In section 4.1.27-T, a pediatrician wants to determine the relation that may exist between a child's height and head circumference. She randomly selects 8 children from her practice, measures their height and head circumference, and obtains the data shown in the table here to your right. So the first column is the height in inches, and the second column is the head circumference in inches. So for part A, it says, if the pediatrician wants to use height to predict head circumference, determine which variable is the explanatory variable and which is the response variable. Well, the response variable is the variable whose value can be explained by the value of the explanatory variable. In other words, the response variable is the dependent variable, while the explanatory variable is the independent variable. Height is the explanatory variable because the pediatrician wishes to use the height to explain the head circumference. Since the height is the explanatory variable, then the head circumference is the response variable. Now for part B, it says we need to draw a scatter diagram. So in order to do that, we're going to use StatCrunch. So I'm going to go ahead and open up the data using StatCrunch. So here's my example. Here's the click to copy to a table. So we're going to open it up in StatCrunch. Okay, so if you notice here in StatCrunch, and I'll pull this back up here, we have the height in the first column, which is the explanatory variable, and the height circumference, which is the response variable. And then we're going to go ahead and then create a scatter plot. So we're going to go ahead and select Graph, go down to Scatter Plot, and then the X variable is the height in inches because that is the explanatory variable. The Y variable is the response variable, so therefore it's going to be the head circumference. And then if we wanted to, we can go ahead and then label what is the X and Y axis. So if we label the X axis, we can call that height, and we can put in parentheses in inches. And then the Y axis is the circumference. And that's also in inches. Okay? And then if we wanted to create a title, we could call it child's height and head circumference. And then from here, we can go ahead and select compute. Before we do that, we just need to make sure that everything is set up correctly. So we do. And so now we can just go ahead and select compute. And then if you notice, we have our scatter plot, which resembles what we have here. So that's how we create a scatter diagram or plot using StatCrunch. Okay, now the next question, they want us to be able to generate the linear correlation coefficient. Okay, so in order to do that, we're going to go ahead and follow the same instructions using StatCrunch. So the first thing we're going to do is select Stat, and then we're going to select Summary Stats, and then we're going to select Correlation. And so in order to figure out what that linear correlation coefficient is, we have to select both the height and also the head circumference, so we have to hit the control button. And then from here, that's all we have to do, and then we're going to go ahead and select compute. And now we're able to then figure out what is the correlation between those two variables. And over, you can see here to the right, they rounded to 3 decimals, so we get 0.793 for R. Okay. Now, the question says, does a linear relation exist between height and head circumference? So we need to first figure out what is the critical value, since we've already found out what the linear correlation coefficient is. So let's go back to the top and then see what is the number of samples. So we have 1 ordered pair, 2, 3, 4, 5, 6, 7, 8. So we have a total of 8 ordered pairs. So that means that n is going to equal 8. So knowing that n is equal to 8, we're then going to use the critical values for the correlation coefficient. So if we go down here at n is equal to 8, we can see that the critical value is going to be 0.707. So the critical value rounded to 3 decimal places with n is equal to 8 is 0.707. So now we're going to compare. So the correlation coefficient, which is the absolute value of 0.793, is greater than the critical value. So therefore, since it is greater than, then we can say that there is a linear relationship between those two variables. Okay, now the next question says, convert the data to centimeters. So we're going to convert the data by going from 1 inch to 2.54 centimeters, and then we're going to recompute the linear correlation coefficient and what effect did the conversion have on the linear correlation coefficient. Now, to convert the data to centimeters, we're going to multiply each data value by the conversion factor of 2.54 centimeters per 1 inch. So each one of these values we're going to multiply times 2.54 and convert it now into centimeters. Okay, now in order to convert it into centimeters, we're going to have to change our data and put this new data into StatCrunch. So just to give you a few examples here, the first number is 27.25 in inches. So we take 27.25 on your calculator and multiply it by 2.54 for the conversion, and then we're going to get 69.215. So here in our first data value, we're going to now replace that with 69.215. Okay, and then just to kind of show you the next one, okay, we're going to do the next one similarly. So we're going to take 25 and again convert that to centimeters by multiplying it by 2.54, and then we're going to get 63.5, so we get 63.5. Okay, so now I've put in all my numbers. I've converted all of these from inches to centimeters, and so now my new data is in here. Okay, and then what I want to do is I want to find out what is the linear correlation coefficient for this information. So we're going to follow the same steps that we did before. We're going to select Stat, go to Summary Stats, and then select Correlation. Okay, we're going to go ahead and put in the height, hold the control button down and select head circumference, and then we're going to go ahead and select Compute. And then what do we get for R? Well, we get R to be 0.793. And so what do you notice about R? Well, if we go back up here, we end up had the same correlation coefficient. So converting inches to centimeters did not change the linear correlation coefficient. So if we compare the correlation coefficient again to the critical value, it's going to give us the same information. So basically what it's saying is the conversion from inches to centimeters had no effect on R, meaning the linear correlation coefficient.